All right, so chapter one is pretty straightforward. This first section's just on linear functions, so this shouldn't be too bad. But let's think about this is kind of going to be where we're leading to. It says the cycle department of a toy store sells bicycles and tricycles. George observes there are 13 cycles in total, and his brother counts 31 wheels in total. So think about, is it possible to determine the number of bicycles and tricycles using only George or only James? What combinations satisfy both? How can we solve this without listing every single combination? All right, so you're going to be seeing stuff like this, and you've got to think, what's going to be the best way to solve this? So first of all, I want you to think about the different ways to represent linear relationships. We talked about this last year. Okay, so think of, first of all, what's a linear relationship? Keyword. So what do you do with a line? You can graph it. And what is the graph formed of? Several coordinate points. What do we do with points? We can create tables, and we can create an equation. Those are all different ways that we can talk about linear relationships. All right, normally we talk about working with a partner, and we're actually going to focus on the graph and the table. We'll get to the equation in just a little bit later. All right, so if it costs $10 to get in and $6 for each ride, how can we create a table? One of the most important things is thinking about which one is your X and which one is your Y. So what does it make sense to make our X? What is changing? What can we change each time? The number of rides. And what are we going to find out? Depending on how many rides is how much it costs. Okay. So if I don't ride anything, if I just go into the park riding nothing, how much is it going to cost me? $10. If I ride one ride, I'm going to pay the entrance fee plus $6. Two rides, the entrance fee plus 6 plus 6. Notice each time this is going up by 6 because that's each ride. Okay. Then we're going to create a graph using this information. A lot of times our graphs go both directions, but it doesn't make sense to have negative rides or negative costs, right? So since rides is our X, 1, 2, 3, 4. So I'm going to label that along the bottom. My Y is in dollars. Okay. And I've got to get up to 34. So I'm going to go 10, 20, 30, 40. And it helps to label. Oops. Your axes. Always label your axes. All right. So 0, 10 is going to be right here. 1, 16, 2, 22, 3, 28, 4. So depending on if you made a nice even distribution, graph paper is much better to do that. It should look linear. Okay, so we're going up. Each ride, we're going up $6. Each ride, $6. Okay. All right. So one of the things that's tough to get used to, gradient is slope. They never use the word slope in IB. It's always gradient. So think of all the different ways that we've ever talked about slope. First of all, what variable do we always use to represent slope? M, right? M is, we talk about it as rise over run. We talk about delta y, the change in y, over delta x, the change in x. And change is when I subtract to see what's the difference between my x's and my y's. And the most important, y is on top because y is what rises. Okay? The y-intercept, that's just where the value of y, where the line cuts the y-axis. Where does the line go through the y-axis? It's that value of y. So the y-intercept always has 0 for the x and a y number for the y. Anytime you need to pause the video, please feel free. The x-intercept is just the value of x where the line crosses the x-axis. So now we have a value for the x and 0 for the y. All right. We can talk about parallel and perpendicular both graphically and numerically. I want to focus about the numerical value. If lines are parallel, we know that they never cross. That's the geometric. We can also talk about they have the same gradient or the same slope. We've talked about this in many of your previous math classes. Parallel lines have the same slope or same gradient. So if parallel lines are the same, what is perpendicular? So if we look on this picture here, if this is gradient M1, notice what type of slope is this? It's going up. This is a positive slope. Gradient 2 is going down. This one's a negative slope. So perpendicular slopes are always opposites because one has to go up, one goes down. And more specifically, it's negative or opposite reciprocal of one another. So using this M1 and M2, we say M2 is negative 1 over the slope 1. A lot of times we use this symbol for the perpendicular slope. Make sure with your notes you're taking the stuff you need. You don't need to write everything down. You can write more than what I write down. You just need to have in your notes what's most helpful for you. All right, so equations of lines we've done a lot with in the past. I just want to make sure we solidify your knowledge, make sure we don't have any gaps. All right, so let's think of the one formula that we've been given so far. That's the slope formula. M equals y2. Actually, I'm just going to leave the y minus y1. And this will just be our generic y. This will be our generic x. This is given 1 point and a slope. All right. Now, if we multiply both sides by the denominator, that's going to be a trick used a lot. Anytime you have a denominator, just multiply both sides, gets everything out of the denominator. Now I'm going to put the m in the front. Do you recognize this? Normally these are flip-flopped. I'm going to put the y on this side. Y minus y1 equals m times x minus x1. We always called this the point slope form. So IB calls it point gradient because they always use gradient instead of slope. All right. What's probably the most common one that you guys know is slope or gradient intercept. And that's your y equals mx plus b. That would actually come from here if we distribute the slope through and then add the y to the other side. That's where this one comes from. And there's a general one, and that's your ax plus by equals c. Now, with this one, be careful. X and y have to be on the same side, and the first coefficient has to be positive. No fractions or decimals. A is positive. So a couple qualifications. Now we're just going to do a lot of manipulating of equations. All right, so be very careful. You always want to identify what your answer should be in. We want to end with the gradient or slope intercept. But really you want to ask yourself, what information are we starting with? We're starting with this gradient or slope and a point. So we're going to actually start with the point slope form. Y minus the y coordinate is -5 equals the slope, -3 times x minus the x. All right, now to simplify this, first of all, I know if I'm subtracting a negative, that just makes both of them positive. Distribute the -3, subtract 5 from both sides. And my final answer, always go back, is in gradient intercept form. All right, so just because it starts with gradient intercept, that doesn't mean you're going to start with it. That's what you end with. So you got to kind of analyze your information and figure out how to get started. Okay, so for this one, they're giving us an equation and they just want us to change it into general form. So general is no fractions. So the first thing I need to do is get rid of that 3. So I'm going to multiply the entire equation by 3. And doing so, that'll cancel this 3 out, and I'm left with -2x plus 6. So I'm multiplying every single thing by 3.
Please excuse the interruption. Ms. Grover and Ms. Harmon, please come to the main conference.
Sorry, guys.
Thank you.
All right, then I need to move the x to the other side. So I'm going to add 2x, and I always want the x to be first. Because I moved the x changed sign, but nothing else did. And this is my ax plus by equals c. So this is my general form. Okay, here I'm starting in general form. I want it in gradient or slope intercept. This just means get y by itself. So first I'm going to subtract 3x from both sides. So that means the 4y stays negative because it's staying on the left. The 3 is moving over. I always push the constant, just push it over to make room for the x because I want it to be y equals mx plus b. So I want my x to be right after the equal sign. Divide each piece, and I would recommend separately by -4. Always, if you've got a negative over a negative, that will become positive, so always simplify that. Positive over a negative is going to be a minus. Reduce the fraction 2/4 to 1/2. And then always double check, is it in gradient form Gradient intercept, yes. All right, so your general form, if it has this slope or gradient and this point, that means I'm going to start with slope, point slope form. Y minus -1 means y plus 1 equals my slope 2/3 times x minus -2 makes it x plus 2 when I subtract a negative. If I want general, I need to get rid of my denominator again, so I'm going to multiply every single thing by 3. Now, when I multiply the left by 3, I end up with 3y plus 3. Now, when I multiply the right side by 3, the 3's gone. So now I'm just left with the 2 to distribute for this equation. All right. General form means x and y on the same side, so I'm going to move my x to this side, so it becomes negative. The 3y did not move, so it stays positive. And I'm going to subtract 3 to move it over to be with the 4, so that's going to give me 1. And I need to make this positive, so I'm going to multiply every single thing by -1, changing every sign, so my leading coefficient is positive. So this is general form, ax plus by equals c, with no fractions and my leading coefficient positive. All right, example 4, gradient intercept is where we want to end with. What are we starting with? 2 points. Okay, so nothing has, think about, actually, the only thing that actually starts with 2 points is your gradient formula. So my gradient formula, remember, is my change in y over my change in x. So if I take my, we'll call this our second point and our first point, because I just like it better that way. All right, so I'm going to take my y2 minus my y1 over x2, move it that way, minus x1, and then I'm going to simplify. 2 minus -1 is 3. 3 minus 5 is -2. Watch your negatives. Your negatives will be the one thing that can get you every time. All right, so you have to have a slope in order to do anything. That's what we just found, okay? Now, I'm just going to choose point A as for my point slope form. So y minus my y value equals my slope. And I'm just going to move the negative from the 2 up to be out in front here. -3/2 times x minus 3. This wants gradient intercept, so I have to get y by itself. So first I'm going to distribute my slope. Remember, when we are multiplying fractions, I'm going to put this over 1. -3 times -3 is a +9. 2 times 1 is 2. Then I'm going to add 2 to both sides. So if I add 2, that's 2 over 1, or 4 over 2 if I get a common denominator. So if I add my numerators and keep my denominator, I have 13 halves. So half the IB test is calculator and half of it is non-calculator. You have to be prepared to do your fractions. Okay, this next example is pretty straightforward. They're giving us an x and a y, and they want to know, does it lie on this line? Does this point make this equation true? So I'm just going to plug in my x and my y. So y comes first. Y is -2. Does -2 equal the opposite of the x? X is +2, so the opposite is -2 plus 1. Does -2 equal -1? It does not. So no, that point does not lie on the line. Letter B. So 3, -1, we're just going to replace the x with 3. I think that's a plus. Yep. Wait a minute here. Nope, that's a minus. 2 times -1. Will that equal 11? So this is 9 plus 2. Does that equal 11? Yes. So yes, this particular point is on the line. All right, last example for the notes. It says if we're given that this point lies on the line, find m. So I'm going to replace my x and my y in the equation. So my y is 3. My x is -2. I'm looking for the m that makes this equation true. So replace the x and the y. I'm going to subtract 7 from 3 and get -4. Divide by -2 to get +2. In order for this point to be on this particular line, m has to be 2. All right, so for letter B, find k. This time this is my variable. So the x is 3 plus 4, y is k, equals -9. We have one equation with one variable. I'm just solving for that particular variable. So subtract 3 from -9, which is -12. Divide by 4. K is -3. And that's the end.